Hi friends, welcome to our channel. Let's have a look at problem 2787, ways to express an integer as sum of powers. So in this video, we are going to explain how to reduce this problem to a standard problem, that is 0-1 knapsack problem. And then we can use dynamic programming to solve the problem. So here, basically, we are given two positive integers, n and x. So we want to write the n into a summation of powers. So the power is x, and this n1 up to nk are some of the unique integers. So we want to find the number of ways to do this decomposition. So here are two examples. You can see 10, you can write like this, 3 squared plus 1. And this is just a one option, right? Because 3, 1 and 1, 3 we regard it as the same, right? So when n equals 4 and x equals 1, so we can write 4 as 4 to the power 1 and also 3 plus 1, right? So here the problem size is not very large because of the range of n and x, right? So our strategy would be the following. First, we want to compute the power given the x, right? Get the powers say, let me see, get the powers within bound, and then use dynamic programming. Let me write the code, and in between we are going to implement the details, right? So first, let's compute the powers. Say pre-compute the powers that are relevant, right? So here, what I'm going to do is we have a powers series array, right? So originally we are at I equals 1. So basically we want to find those power to the x which is less than or equal to m, right? So let's see, the power will be I to the power x, right? If p is greater than n, so we just stop. Otherwise, so powers will be append to this p, right? So we increment I. So this way you can print out the powers, right? So let's run it. For example, for 10, so we have 1, 2 to the power 2, 3 to the power 2. And then we don't need to consider 4 to the power 2 because it's larger than this n, right? So we have this powers array. And then the problem reduces to the following. So 0-1 knapsack. So what we want to do is to find the number of ways to form the sum n using elements in powers in this array, right? So typically for this we use dynamic programming, which is very well known. Let me first write a 1D 2D dynamic programming, and then we do a 1D dynamic programming, right? The 2D is just for digestion or for details. So here, let me first get the m. M is the length of powers, so how many elements we are going to use. And then what I'm going to do, I'm going to initialize this dp. So here is 0 times m plus 1 for dummy index in range, say here, right, m plus 1. So the interpretation of dpij is the number of ways to decompose j using I elements. So here I is not index, is the number of elements. Therefore, I is running from 0 to m, right? Because we have m elements. There are m plus 1 possibilities from 0 up to m. So with that said, let me first decide the first column, right? So for I in range say m plus 1, so dpi is 0, right? So it's just one way. So no matter how many elements you have, if we want to get 0, you choose nothing, right? This is the one way. So this is the dp initialization. So now let me write more details here. And dp initialization, and then next is dp update. So for dp update, so we have for I in range, so it's because we have if it's 0, so we just don't need to consider any others. So plus 1, because the first row is just 0. Only the first element should be 1, right? All the other element in 0th row should be 0. So for I in range 1 to m plus 1, so therefore ending at m. So notice that again I is the number of elements. So for j in range, so we have considered j equals 0. So we consider j equals 1 up to n, right? Then first dpij. This is the number of ways to decompose j using I elements. So at least we have this number of ways. If we use I minus 1 element, so we decompose j, right? And then we consider the power, the current element, as the powers at index 1. This is the s element, right? If this guy is greater than j, we don't need to consider. It's less than or equal to j. What we do? So here we should write like increment. So dpij is incremented by this one. So dp I minus 1. So we use at most so here let's see at most I plus 1 elements from the beginning. Then we can form this one, j minus powers I minus 1. So if we use I minus 1, at most I minus 1 element to form this one, then we can use the current element to form the j, right? So after we do the update for dpij, right? So we need to take care of the modulation operation. So just mod this large constant, right? In other words, 10 to the power 9 plus 7. So once we have this, so we can return dp. So we want to use m element to decompose n, right? Let me first run it. Yeah, it passes the two cases. Now let's look at the generic case. Yeah, it passes all the cases. So for further details, you can do some print operation. So for example, print the current dp and then the final state of the dp. So you can run it. So if you look at this one, so the last element should be 1, right? So if you look at the second test case, so this will be the final state. So this is a 2D version of the dp. Let me copy this one and write another version. So the reason I write it this way is for details, right? So if you are very familiar with 101 knapsack problem, you can write a 1D knapsack, 1D dynamic programming. Let me just delete all those. What we want to do is this. So I'm going to initialize a dp. So dp will be 0 times let's see m plus 1. So the interpretation of dpi is the number of ways to decompose I using number elements in powers, this array, right? So dp0 in parallel to this this one should be 1, right? Choose nothing. So this is the one. And then we're going to iterate over the powers. For power in this one, then we consider the sum in range, so from n to p. So we don't need to consider the s that is smaller than this p. So decrement is -1, right? So dps will be the previous state and plus this way. So if we can form s minus p, right? And then we use the current p to form another way. So this way we just modulo this one by this mode, right? And after this, so we just need to return this dpn. So this is another way. Let me run it. Yeah, it passes the two cases. Now let's submit. Yeah, we get another way. So these two ways are essentially the same. But for me, I feel that the first version, 2D for digestion actually gives you more detail, right? So with that said, I guess that's basically about it for the current daily challenge problem. Thank you for